When American hardcore technology meets China's agile innovation, an ultimate showdown in robotics is about to unfold. Boston Dynamics showcases the raw power and precision of Atlas, pushing industrial AI to its limits, while Unitree Robotics from China disrupts the market. With its astonishing agility and unbeatable cost-performance ratio, will brute mechanical force reign supreme, or will intelligent dexterity take the crown? A fierce clash of speed, strength, and intelligence. The battle of technology begins now.
Ready, go!
technology has propelled societal progress, and we are an integral part of this transformation. Hopefully, in the future, AI robots will bring us safety and comfort rather than threats and harm.
The core reason people are so interested in humanoid robots today is the promise of a truly flexible robotic solution that can switch between tasks and applications in a way that we just haven't seen before in robotics. The world was built for humans, and the huge promise of humanoids is that they will be able to enter into those human-built environments and immediately add value.
The previous generation of Atlas was able to do a lot of really athletic things, from running around, jumping, flipping, and so on. And so that made it a really interesting research platform for us to explore the limits of full body control. But there are some downsides to hydraulics as well, right? They're very complex, they're quite expensive, they're difficult to maintain, and they're messy. Our old lab used to have a thin coat of oil on it at all times. And we got to the point in our humanoid development where we realized that using the battery technology that we developed on the previous generation of Atlas, and by building our own electronic actuators, that we could build a humanoid that was strictly faster, strictly stronger, and more compact, and less messy. Just manipulating objects is something that people spend very little time consciously thinking about. We've had an entire lifetime of interaction with the world to train our control system so that we know how to predict what's going to happen, and we know how to send commands to different parts of our body in order to achieve manipulation tasks. Robots, by and large, do not have that wealth of experience. And part of the exciting work that is happening in AI, and that we're doing ourselves as well, is trying to use the rich data sources that we are generating now from all of our robots, whether they're deployed out in the real world, whether they're in our labs, or whether it's being generated in simulation, in order to train models that have a similar ability to generalize and a similar ability to error correct when trying to do fundamentally new manipulation tasks. And I think that's one of the places where I would expect AI to significantly change how we perceive the capabilities of robots over the next couple of years.
Sequencing is a logistics task in the automotive manufacturing world that was created in order to allow manufacturers to produce many different customizations and variations of vehicles.
Sequencing has commercial value, but also from a research perspective, from a building blocks perspective, has a lot of the complexities that we think are necessary to be able to develop general purpose manipulation robots.
The sequencing process is taking thousands and thousands of different variants of parts and putting them into the specific order in which cars are going to be produced, making sure that the cars can be produced more quickly and more accurately than they were before.
For this task, we've given Atlas a basic description of the end state that we want. So we have this output dolly that needs to be filled with engine covers in a particular order. And we've also given it a description of where it can look to find those engine covers. Once it has this, it basically goes in order of the output dolly. So it picks, say, the first slot in the output. What kind of engine cover do I need? And then consults where can I find that? And then it goes and tries to pick it up from there. And if it can find it, it proceeds. It has that kind of basic description, and then it has a description of the kind of whole architecture of the task that we've provided. And then it puts those two together to do the sequencing.
Atlas has cameras, mostly in the head, and with those cameras, it perceives the fixtures or containers that it has to interact with, not just the one in particular where it has to extract an object or insert an object, but all containers around it so that it can map its footsteps to avoid collisions, for example. And then at the same time, it also sees objects. It has an idea of the object that it's going to manipulate, and with that mental model, it sort of uses directly RGB cameras to estimate the pose of the object and then equally track it over time.
Sometimes it knows that it's successfully put in place. So it knows that it's failed if it starts pushing and senses that it's not being able to move the cover the way it wants to, and then it'll back up and try again. It'll get the cover in and then let go. And at that point, it thinks that it has successfully put it in place. It'll go ahead and give it a little extra push just to make sure it's fully seated.
The 360 rotations are funny. They're there for a very particular reason, which is efficiency, right? So Atlas can turn around faster, can turn its head It wants to look something behind its head, and it can just turn the head. Atlas is faster at moving back and forth because it has that 360 motion.
Boston Dynamics has a very long history in robotics, and in particular legged robots. And in bipeds alone, we've been working on them for probably over 15 years. But we really designed it to be a very high performance machine. And so we're interested in, again, being able to explore the very frontier of what's physically possible in humanoids. And everything, all the infrastructure we've built around doing that, I think is a real accelerant that shows itself through the performance of Atlas already.
I'm biased. For me, it's the pinnacle of humanoids today. It's capable of all of the agility that HD Atlas had, but probably even more than HD Atlas.